This is Algebra Lesson 2-3, solving multi-step equations. To solve multi-step equations, you form a series of simpler equations. To do this, you use the properties of equality, inverse operations, and properties of real numbers. You use the properties until you isolate or get the variable all by itself on one side of the equation. So many problems require more than 2 steps to solve. Here are probably the easiest way to think about the steps to solve a multi-step equation. Number 1, collect all the like terms on one side of the equation. Number 2, distribute when necessary. And sometimes you have to distribute before you can collect like terms. Be careful with that. 3, isolate the variable and then solve. So let's take a look at a couple of examples here. Here we have a couple of examples. We're going to solve 2c plus c plus 12 equals 78. Now, normally when variables are next to each other, people realize that they need to combine them before they move things from one side of the equation to the other. So I can clearly see here that 2c plus c is on the same side of the equation, so I need to combine them together. 2c plus 1c. Remember, if there's no number in front of the variable, if there is an implied 1. So this becomes 3c plus 12 equals 78. So we've combined our like terms, which happens to be our c's. So now all we need to do is undo anything added or subtracted, and then undo anything multiplied or divided. So we're going to subtract 12 from both sides of the equation, and we'll have 3c equals 8 minus 2 is 6, 7 minus 1 is 6, 3c equals 66. Now, since they've multiplied c by 3, we're going to undo the multiplication by 3 by dividing by 3. So 66 divided by 3 is 22, so c equals 22. And of course, we should check our answer. Check my answer. 2 times 22 plus 22 plus 12 is supposed to equal 78. So 44 plus 22 plus 12. 44 and 22 is 66. 66 and 12 is 78. So 78 equals 78. It does indeed check. Problem number 2 here. 3x minus 4x plus 6 equals negative 2. Again, I can see I have x's right next to each other. So I need to combine 3 and negative 4, which becomes negative 1. So 3x minus 4x is negative x plus 6 equals negative 2. So to get rid of the 6 that is added to the x, I'm going to subtract 6 from both sides of the equation. I get negative x equals negative 8. Divide both sides by negative 1 to get x to be positive, so x is going to equal 8. So I will check that to make sure that I am correct. So 3 times 8 minus 4 times 8 plus 6 is supposed to equal negative 2. So 24 minus 32 plus 6 is supposed to equal negative 2. Well, 24 minus 32 is negative 8. Negative 8 plus 6 is indeed negative 2, so that checks. Lost my negative sign. There we go. And last but not least, number 3 here. 3a plus 6 plus a equals 90. Now here's where it gets a little hairy. Sometimes people look at this second a, the one that's after the 6, and think they need to subtract it from both sides of the equation. It's on the same side as the 3a, because remember, find your fence line. Your fence line is the line that goes between the equal sign. And I'll use the highlighter so that's not quite as terrible to try to see through. So there's my fence line right there. So if that's my fence line, I need to combine anything that's on the left side of that bright green line. So I see I have a 3a and a positive a, which makes 4a plus 6 equals 90. Don't get into the bad habit of thinking I should subtract that second a because it's separated from the 3a. A lot of people do that and they end up with some really bizarre answers. It's on the same side of the equation, so you combine like terms. You don't undo it yet because it doesn't need to be undone. It's not on both sides of the equation. There's not an a on one side of the equal sign and another a on the opposite side of the equal sign. So 4a plus 6 equals 90. Subtract 6. So I will have 4a equals 84. To get a by itself, divide by 4. A will equal 21. And of course, I should check my answer. 3 times 21 plus 6 plus 21 is supposed to equal 90. 21 times 3 is 63 plus 6 plus 21. Well, we'd have 63 plus 6 is 69. 69 plus 21 happens to equal 90. So it checks. All right, a couple of word problems here. You need to build a rectangular pen in your backyard for your dog Fido. One side of the pen will be against your house. Two sides of the pen have length of x feet, and the width will be 25 feet. What is the greatest length the pen can be if you only have 63 feet of fencing? So I have 63 feet of fencing, but I must make a pen for Fido. So I need to know what is the greatest length that the pen can be. So that's going to help me figure out what my variable is. All right, so I'm going to let, I can't use x because I have x feet already. Well, actually I can. Okay, two sides of the pen have length x. Because it actually told me that, so I'm going to let x equal length. Now, let's draw a little picture here. Here's my house. Let's just say I live in a rambler. Here's the back of my house. I'm going to make a little pen. My pen is going to become something like this. I'm going to use the house as one of the sides so I don't have to use fencing. And it says the width is 25 feet. So here's 25 feet. Each length is x feet. So there's x and there's x. We only have to fence 3 sides of the pen. Okay, because we're using the house as the third side. So we only need to fence the sides that are in yellow, highlighted in yellow. So then all I have to do is my side plus my side plus my side has to equal the amount of fencing that I have. So side plus side plus side equals my length of the fencing has to equal 63. So one side is x, the width is 25, the other side is x, and then it has to equal the 63 feet of fencing that I have, because I only have 63 feet of fencing. So I'll combine my like terms, this x here and this x here, x plus x equals 2x plus 25 equals 63. So to solve this, I will undo the 25 first, undo the addition, so subtract 25 from both sides. That gives me 2x equals 38. Divide by 2, and x equals 19. So the longest length it can be is 19 feet, which means my picture's a little not drawn to scale, but that's okay. So the greatest length the pen can be is 19 feet. It could be shorter than 19 feet, but at the longest length it could be is 19 feet, which makes sense. Because if I rounded it up to 20, that'd be 20, 40, 65, and I subtract 2 from that, that makes 63. That works. It does check. All right. Noah and Kate are shopping for new guitar strings in a music store. Noah buys 2 packs of strings. Kate buys 2 packs of strings and a music book. The book costs $16 and their total cost is $72. How much is 1 pack of strings? Okay, so we need to know how much is 1 pack of strings. So first thing we do here, we define our variable. I'm going to let C equal the cost of 1 pack of strings. I'm looking at this going, the amount of money that Noah spent plus the amount of money that Kate spent has got to equal their total. That kind of makes sense. All right, Noah buys 2 packs of strings. So Noah buys 2 times the cost of a pack of strings, so that'd be 2C. Kate buys 2 packs of strings, 2C, plus she also buys a music book. The music book costs $16, and their total is 72. So here's Noah's cost. Kate's cost is that. So Noah's cost plus Kate's cost equals the total. So 2C plus 2C plus 16 equals 72. 2C plus 2C here is 4C, so 4C plus 16 equals 72. Undo addition or subtraction first, so subtract the 16. So 4C equals 56. Divide by 4 to get C all by its little lonesome, and C equals 14. So it looks like strings cost $14 a pack. Let's check this out and make sure this is right. So checking this, 2 times 14 plus 2 times 14 plus 16. So 28 plus 28 plus 16. Well, 28 and 28 is 56. 56 plus 16 is 72. So that checks out. So 1 pack of strings costs $14. So 1 pack of strings cost $14. Alrighty. Now, sometimes you have to distribute before you can combine like terms because you have a variable inside of your parentheses. So whenever you have a variable inside of your parentheses, you most likely have to distribute before you can combine any like terms. So be careful, especially with negative signs, so that you don't lose those negative signs because that will mess up your entire problem. So let's take a look at a couple of examples here. 2 parentheses x minus 3 equals 8. So let's distribute this 2. So 2 times x is 2x. 2 times negative 3 is negative 6 is equal to 8. So 2x minus 6 is equal to 8. Once you've got it like that, it's just a typical two-step equation, and we're going to solve this two-step equation. Add 6, add 6. 2x is equal to 8 and 6 is 14. Divide both sides by 2. X is equal to 7. And we should check it. Oops. 2 times 7 minus 3 equals 8. Well, 7 minus 3 is 4. 2 times 4 does indeed equal 8. That checks. Problem number 2 here. Be very careful with this negative sign. Keep my 15. Multiply my negative 3 through. So negative 3 times x is negative 3x. Negative 3 times negative 1 is positive 3. That's the biggest mistake most people make. They lose that negative sign on either the 3 or the 1, and it ends up to be negative, and that messes up everything. Plus 9. So now to combine like terms, I can add the 3 and the 9, so I have 15 equals negative 3x plus 12. So to solve this, subtract the 12. 15 minus 12 is 3 equals negative 3x. Divide by negative 3. And x equals negative 1. Again, we should check this. 15 equals negative 3 times negative 1 minus 1 plus 9. So negative 1 minus 1 is negative 2. So 15 equals negative 3 times negative 2 plus 9. So 15 equals negative 3 times negative 2 is 6. 6 plus 9 is 15. That does indeed check. Problem number 3. Again, don't lose your negative signs. Be really careful. We're looking at multiplying a negative 3 times everything in here. So we have 3 minus 3x plus 15 equals 69. So combine like terms, 3 and 15, that makes 18. 18 minus 3x equals 69. Now we need to get x by itself, so I'll subtract the 18. Don't lose your negative sign on your x, so it's negative 3x equals 69 minus 18 is 51. Divide by negative 3, and x will equal negative 17. Alrighty, now you can use different methods to solve equations that contain fractions. There are two ways to solve them. I do not have a preference over which method that you use. I have a preference of my very own, but that's my own personal opinion. You can use whichever method that seems to work best for you, that you are most accurate with and you're most comfortable with. I will show them both here. So method number one is to get a common denominator and solve. So if I have the equation m divided by 4 plus m divided by 2 equals 5 over 8, lots of fractions. I need to get a common denominator between 4, 2, and 8, which happens to be 8. So my least common denominator is 8. So I need to convert all of these to eighths. Well, m divided by 4, I have to multiply by 2. M divided by 2, I have to multiply by 4, and the 5 I can leave alone. So this becomes 2m over 4 plus, excuse me, over 8, because I multiplied by 2 over 2. And this is 4 over 4. So this is going to be 2m over 8 plus 4m over 8 is equal to 5 over 8. So now we have a common denominator of 8. Okay, so 2m plus 4m is 6m, so I have 6m over 8 is equal to 5 over 8. So to get rid of this 6/8 m, I'm going to multiply by the reciprocal, which is 8 over 6. So these cancel, leaving me with a happy little m. And on the right-hand side, the 8's cancel, leaving me with a 5/6. So m is equal to 5/6. Okay. The second way is to clear all your fractions from the equation altogether. Again, you'll find what your least common denominator is. My least common denominator is equal to 8. So instead of getting a common denominator of 8, I'm going to multiply everything by 8. So I have 8 over 1 is going to be multiplied by m over 4, plus 8 over 1 is going to be multiplied by m over 2, and that's going to equal 5 over 8, which is going to be multiplied by 8 over 1. By doing that, 4 goes into 8 2 times. I have 2m. 2 goes into 8 4 times, plus 4m. 8 goes into 8 once. That equals 5. So I now have 2m plus 4m is equal to 5. 2m plus 4m is 6m. 6m equals 5. To get m all by itself, divide by 6. So m is equal to 5/6. Okay. Both methods work. Both methods are effective. I happen to prefer method 2 just because that's what I seem to think works is a little bit easier for me, but you do whatever method works best for you as long as you can do one of the two methods. So let's look at some examples. So if I have 3/4 y minus 1/2 y equals 5, I'm going to get rid of all my fractions because that's what I like to do. So my least common denominator of 4, 2, and 1 is 4. So my least common denominator is equal to 4. So I'm going to multiply everything by 4. So I have 4 over 1 times 3/4 y minus 4 over 1 times 1/2 y equals 4 over 1 times 5 over 1. So these 4's cancel, leaving me with 3y. 2 goes into 4 twice. 2 times y is 2y, so minus 2y. Don't lose your negative sign. And then 4 times 5 is equal to 20. So 3y minus 2y is equal to 20. So you have 3y minus 2y is y, so y is equal to 20. Fairly simply done. And I can check those. I'm just going to tell you for right now, those check out quite nicely. Number 5, my least common denominator here is going to be 20. So I'm going to multiply each one of these by 20. So 20 over 1 times 1/2 plus 20 over 1 times 7x over 10 equals 13 over 20 times 20 over 1. I don't know why I did 20 over 1 last instead of first, but it doesn't really matter because multiplication is commutative. Order doesn't matter. 2 goes into 20 10 times, so this becomes 10. 10 goes into 22 times. 2 times 7x is 14x. 20 goes into 20 once, and 1 times 13 is 13. So now I have 10 plus 14x is equal to 13. To solve this equation, get all the x's by itself, so I have to get rid of this 10. So I end up having 14x is equal to 3. Divide by 14, divide by 14, so x is equal to 3/14. As a general rule, if your equation had fractions in it, you need to leave your answer in fractional form versus decimal form. If your equation has decimals, you leave your answer in decimal form. If it has both, you choose a form, unless, of course, your decimal doesn't terminate, then you leave it as a fraction because fractions are exact. All right, the last part of this. You can clear an equation of decimals by multiplying by a power of 10. That helps you greatly, especially if you don't have a calculator handy, because we tend to make mistakes when we're using decimals and doing paper pencil versus a calculator. So first you find the greatest number of digits to the right of any decimal point and then multiply 10 raised to that power. For example, if we look at the first problem here, I have 0.025x plus 22.95 equals 23.65. So I have 3 places after the decimal point here, 2 and 2, so the greatest is 3. So I need to multiply it by 10 to the third, which is a 1 followed by 3 zeros, just in case you didn't know that. So I'm going to take this entire equation and multiply by 1,000. So instead of having 0.025x, I have 25x plus, move the decimal point 3 places to the right, 1, 2, 3, add a 0. That's 22950 is going to equal 23650. So 25x is equal to 22,950. Plus 22,950 is equal to 23,650. Okay, so to solve this, I'm going to subtract 22,950 minus 22,950. That gives me 25x is equal to 700. Divide by 25. So x is going to equal 28. And I have a nice little whole number there. Sometimes when you solve a decimal equation, the answer will end up to be a whole number, and that's perfectly fine. Number 2, if I look at this, it looks like I have 1 digit behind the decimal point in each one of these problems. 0.2, 0.6, 0.3, 0.4, so I need to multiply everything by 10 to clear the decimal. So that gives me 12x minus 36 plus 3x is equal to 24. Combine like terms, this 12x, this 3x are on the same side of the equation because they're on the same side of the equal sign. That makes 15x minus 36 is equal to 24. Add 36, add 36. These cancel, so I have 15x is equal to 60. Divide by 15. X is equal to 4. So clearing an equation of fraction, and clearing an equation of decimals. All right, our closure question for this, please answer this in your notes. Please write a complete answer. There's often more than one method for solving multi-step equations. How can you decide which method to use? How can you decide which method to use? Answer that in your notes, please.